Good day, my SS1 students. We are still continuing with our linear inequalities. Our specific objective, at the end of the lesson, the students should be able to do the following: the inside boundary shading of the Cartesian graph of inequalities, and then the outside boundary shading of the Cartesian graph of inequalities. The Cartesian graph of inequalities continue. So as given to you on assignment, you are required to represent the following inequalities on a single Cartesian graph. You have already known how to represent a given inequality on the Cartesian axis, but here you are to represent 1, 2, 3 on the same graph. Whatever you are going to do there is actually called the inside boundary shading. Inside boundary shading simply means the required direction of a shading. So by solution, the first one says s is greater than 1. We have to shade s is greater than 1. We also shade y is greater than minus 1. It is actually called inside boundary shading. Then we come to the third inequality, which says 2x plus 3y is less than 12. Remember, if we want to find what x will be on its own axis, we will take that the value of y is 0 and put in the 0 as a value of y. Look at it here. 2x plus 3y is less than 0. Then 2x plus 3 into 0, we have taken y to be 0. That is moving along x-axis. So it's less than 12. We come to see 3 multiplying 0 is 0. So that 2x plus 0 is less than 12. Showing that 2x is less than 12. What do? We divide both sides by 2 to get x is less than 6. Don't put equality so that you will know the direction of the movement. Please stop that. Okay, we continue. If we want to know what the value of y will be on its own axis, we put 0 for x. So 2x will mean 2 multiplying 0 here. Then plus 3y is less than 12, which shows that 0 plus 3y is less than 12. Almost finally, we get 3y to be less than 12. And when we divide through by 3, we get y to be less than 4. So what are we going to do? We put the points on x-axis where x is 6 and show the direction towards all numbers less than 6. We pick the points on y-axis where y is 4 and take the direction where all values are less than 4, remembering that you have shaded x greater than 1 and y greater than minus 1. We go and see what the graph will look like. You can see the shading in red is talking about x greater than 1. So you can see at the center of 0 and 2, we have 1. S greater than 1. The shading in green shows y greater than minus 1. And the shading in blue is talking about 2x plus 3y less than 12. So the region of definition of all these inequalities, which will be called the feasible region, is the region where we have the greatest density of the lines. I think that thing should be stopped. So the region where we have the greatest density of the lines, where the three lines intersect with one another, that's where we have what we call the solution of the three inequalities at a time, known as the feasible region. You can see it within this triangle, but in order to see it clearer, we do what is called outside boundary shading. The outside boundary shading is not even the correct shading anyway, but it is done in opposition to what is supposed to be done, so that the denser region is made open so that we can actually see the region clearly. So we go ahead to see how it is done. We say outside boundary shading. You have seen how difficult it is to see everything about the graph, which makes it difficult to see the region of definition of the general solution. That means what I was telling you here, you know, it requires a little stress of the eyes in order to see the region where all the three graphs intersect one another. However, it is easier to see here because we use different colors to shade each of the graphs. We say in order to see it clearly, we do the graph work again, but using outside boundary approach. The outside boundary means instead of shading towards left, take it towards right. Instead of shading upwards, bring it down. Is it okay? Just shade the opposite. You can now see, remember, when we did it the first time, where we shaded the right thing, this is exactly what we did before, where x is greater than 1. But you can see, this direction does not imply x is greater than 1. It actually implies x less than 1, which is the opposite of x is greater than 1. That's why we say, do the opposite of what you are supposed to do in order to show the outside boundary. Then the green one having y greater than -1 should go upwards, but it is coming downwards, which is the opposite direction. Then 2x plus 3y less than 12 is supposed to come down, but is going up, leaving open the triangle of definition, which is the region of solution of the three inequalities, showing the feasible solution. The feasible region is the open triangle here, within which, when you stand, let me actually tell you the meaning. The meaning is that when you stand anywhere within this region, okay, let's assume we stand somewhere here. This place, you can see x is 3 here, and y is something 1. Where x is 3 and y is 1, we see x3, y1. We will check if all the inequalities will remain true within that region. When x is 3, we check if x is actually greater than 1. Yes, it is greater than 1 because 3 is greater than 1. But at that particular point, where x is 3, we have gone this way to sense that y is something 1. If something 1 is what y is representing, we shall go and check if it is actually greater than -1. Of course, you know that 1 is greater than -1. So that's why we say that this particular place is the feasible solution, the feasible region, where all the inequalities stand to be true. Still talking about it, that point, where we have chosen x to be 3 here and y to be 1, we go and combine them to check if everything combined together will be less than 12. So we say 2x means 2 multiplying 3, which is 6. 3y means 3 multiplying 1, which is 3. 6 plus 3, what is it? 9. Is 9 not less than 12? 9 is less than 12. So as a result of that, stand here, go down, you get 3 on x, stand the same place, go this way, you get 1 as y, 3 multiplying 1 is 3, 2 multiplying 3 is 6, 6 plus 3 is 9, and that 9 is less than 12. That's what we mean by the outside boundary shading in order to leave the solution space open for proper visibility. Then we check if we can do more. Here we say more examples. You should actually read more examples because I think it is only one more example that we have here. So I say using graph, show the region that satisfies the following inequalities. Here we have decided to use the outside boundary shading, since it is the outside boundary shading that will always open up the region of definition of all the inequalities at a time. It means that the outside boundary shading will always open up the feasible region where we can choose values that will satisfy all the inequalities from the axis x and the y. So the first inequality here says 2x is greater than 1. Second one, y is greater than 1. Next one, x is less than y. You have to be very watchful here while we are doing it. Here we say x is less than y. Most of the time, students find it difficult to represent this on the Cartesian axis. So the last one says 3x plus y is less than 6. Remember, when equality is contained in this sign of inequality, you remember to make use of continuous line, which means thick line instead of dotted line, whenever I want to represent a given inequality that contains such a thing. So we go on. The first one says that 2x is greater than 1. What does it mean? When we divide both sides by 2, we get that x is greater than half, which is 0.5. The second one has already told us that y is greater than 1. And the third one says x is less than y. It is talking about both x and y again. So we choose which one is going to be this and which one is going to be that. Actually, when we subtract y from both sides, we shall get that x minus y is less than 0. I think you can do it. Here, subtract y from both sides. You can equally decide to subtract x from both sides. You will still get the same result. So having seen it like this, we say for us to choose a value for x or the direction for x, we move along x-axis, which means nullifying everything about y, showing that y is taken to be 0. If that is done, x minus y less than 0 will now read x minus 0 less than 0, which automatically results in x is less than 0. So we shade a direction where x is less than 0. Do the same thing for y by nullifying putting x to be 0. We see instead of x minus y to be less than 0, it will read 0 minus y to be less than 0. However, minus y being less than 0, recall what we said, that whenever we are dividing by a negative number or when the coefficient of the variable becomes negative, in order to make it positive, the sign of inequality must reverse. So here we shall be dividing by minus 1, which reverses the sign of inequality from less than to greater than, showing that y is greater than 0, if minus y is less than 0. The fourth one. Actually, we are given 2x plus y is less than 6. 3x plus y is less than 6. Now, 3x plus 0 is less than 6 here means we want to find the direction of movement of x along the x-axis where all values of y will be 0. If that is true, we put 0 for y to stand in this form, and we get 3x plus 0 to be less than 6, showing that 3x is less than 6. Then upon division of both sides by 3, we shall get This divided by 3 is x, and this divided by 3 is 2, showing that x is less than 2. Direction of shading, you shade towards all the points less than 2 along x-axis, but you must connect the 2 points first on the x and the y-axis. Going by what we did before, we put 0 for x to find where y will be heading to, and we end up getting that y will be less than 6. What do? We go to the graph. The graph. The red one, x is greater than 0.5. 0.5 is between 0 and 1. At the center of 0 and 1 is 0.5. That's where we position it. Instead of shading greater than, we are shading less than as the opposite of what is given. That is what is actually called outside boundary shading. Next one says s is greater than 1. The green one is y is greater than 1 anyway. The green one is showing where y is greater than 1. 1 is between 0 and 2. Where y is greater than 1, instead of going upwards to indicate where y is greater than 1, we go downwards as the opposite of what we're supposed to do. Look at it, y is greater than 1 did not go up but came down, which means opposite. Then the blue one, for 3x plus y to be less than 6, instead of shading less than as is supposed to be indicated, we shaded upwards, which is greater than, showing the opposite of what we need to do. Then, x is less than y. At a point, what did we see? X is less than 0 in this way, and y is greater than 0 in this way, which means the direction of shading should be this way, it should be this way, it should be this way, but we have now decided to shade it backwards. In order to shade it backwards, it means we want to see the solution, the space that defines all the inequalities at a go. Now, standing here, you can see the space. This space is not triangular. You can see it. 1, 2, 3, 4. So the shape looks, it has something 4 sides. And remember, a 4-sided plane shape is called a quadrilateral. Do you understand? Having seen it, we shall try to check if it is possible to pick a point where we can locate the x and the y coordinates and choose the coordinates to check all the inequalities to know if it will give us true results. What do? We pick 1, go upwards, go to 2. So it means x is 1, y is 2. If x is 1 and y is 2, we check it here first. Is x less than y? Yes, because 1 is less than 2. Now, what's the value of y there? It is 2. Is y greater than 1? Yes, because 2 is greater than 1. What's the value of x there? 1. We go here. S is greater than 0.5. Is 1 greater than 0.5? Yes. So it is true. Next. X is 1, y is 2. We check. If x is 1, 3 multiplying 1 is what? 3. Plus 2 is what? 5. Is 5 less than 6? Yes. Therefore, this space is a region of definition of all the inequalities given. How many of them? 1, 2, 3, 4. So this space is where you can pick points. It is not only 1 and 2 that you can pick. You can pick 1 point something and another number. When you use graph book and do this particular work, you can see as many points as possible that you can choose that will satisfy all the inequalities at a time. The objective of using the outside boundary shading is for clearer vision of the space of definition. However, if you understand this very well by going through it one time and another, it will now be the forerunner to understanding the maximization of the objective functions subject to some given constraints when we shall go into optimization. That's linear programming continuing. The assignments. Using outside boundary shading, you are to show the region that satisfies all these inequalities at a time. Then, if there is no such region, say why there is none. Here we go. I think we have come to the end of the class, my dear students. We say thank you very much for watching. Stay safe as you stay at home, but do not give your back to your mathematics. Continue going through your mathematics work and getting ready to understanding it better by going through your textbooks and some other materials that you may find around you. God bless you. Good night.